All right, let's see how this does today. Okay. All right, no guarantees, of course, with this. Hopefully it works, hopefully it doesn't, or hopefully it works. Not hopefully it doesn't. Observation versus inference. Okay, observation versus inference. Yesterday, we kind of looked at this thing versus the science-minded method, and it's still up on the board over there. Okay, and where we kind of talked about how there are just a few key things, and they are, one, that it is not just a start to finish process. What do I mean by that? I mean, it's not a recipe. Okay, you can't just do this, 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 and this, and this, and then we say science has been done. Okay, it is a way we think. Therefore, it's more of a way to solve problems. It's like problem solving. It's not, because I could go observation, inference, questions, answers, past research. Stop. I could go observations, inferences, questions, answers, experiment, observations, inferences, questions, answers, experiments, questions, answers, experiment, questions, answers, experiment, observation, inferences, question, answers, experiment. I could go to present your findings in writing. Other scientists repeat, so then we have to go back, observations, inferences, questions, experiment, observations, inferences, questions, experiment, questions, answers, experiment. Then it might go out there again, and then they might revise it again. We'll go back, observations, inferences, questions, experiment, and then etc. So it could take, or we could just go observations, inferences, questions, and stop. Okay? Oh, no. You know better. Okay. So, the whole point here, okay, is that this is not a set recipe. That you could take a lot of different approaches. There's a lot of directions it could take. That we don't want to just say science is the same thing for every scientist. Every scientist has to look at the problem they're trying to solve uniquely and take a unique approach to solving it. What we do, though, is that we do make observations. We do ask questions. And then the important part, which is why we're going to spend a lot of time with it, is how we design the experiment. Because if we don't design the experiment right, everything afterwards is useless. Because of that part right there, it says present your findings in writing. If we give other scientists a foothold to rip our findings apart, okay, because we did the experimentation wrong, then what we've done is going to be completely undone. Okay? But if we do it right and we set up the experiments well, then scientists won't be able to find loopholes, and then our evidence will be sound, and therefore it will be credible and useful. Okay, so the experiment is really the key focal point of the whole thing. All right? Now, before we get to the whole idea of an experiment, okay, this is kind of review for you, experiment versus demo, where an experiment, we kind of talked through this yesterday. Experiments are what? They have what? Yes? They have parts, okay? Do we know the outcome? No, we're trying to test something. We don't know the outcome usually. And when a demonstration, does the person performing the demonstration know the outcome? No. Yes. Does. When you perform a demo, do you have to do it multiple times for it to be effective? No, you could do it once. You could do it once and it'd be effective. For instance, in chapel, I did the whoosh bottle experiment. I did it once. It was fairly effective. People remember it. Okay? Now, a demo, though, is only effective as a demonstration if you explain what it is you're showing. If you show something and then you're like, ooh, it's nothing more than like a pyrotechnic display if it involves fire, or some kind of cool ooh, moment, or, magic show, whatever you want to call it. Okay? All right, today we're going to kind of do this. This is new. We didn't go over this last year. Okay? Observation versus inference, the ultimate showdown. All right, so this is going to actually be from our packets. So the packets that you were given, please take them out. We're going to work out of those today. Observations versus inferences. Sometimes it's very hard for us to distinguish what's an observation and what's an inference. Observations, remember, are based on the 5 what? Senses. Okay? Sometimes, though, our brains right away, without us even try to make sense of these observations. Okay? So whatever we see, So for instance, he's got orange on. That's an observation. Okay? His hair is brown. That's an observation. All right? I see water in the road. That's an inference. Why? Well, let's just say I could see the road and I was at a distance. Why would I say there's water in the road? Why is that an inference? Yes?
Because there's not actually water in the road. It's just your brain thinking, making sense of it.
Okay, if we're talking about a mirage, yes. But let's say that I look out there and I see the road and I see what looks to be water on the road. Okay? And I say there's water on the road. What's the problem with that? Yes?
There's not really any water on the road. It's just...
But let's say there is a liquid on the road. Yes?
You don't have any evidence that it's really water.
I don't have any evidence it's water. What other clear liquids could it be? Yes? It could be gasoline. Absolutely. It could be gasoline. It could be alcohol. It could be any sort of toxic chemical that has been spilled. I don't actually have evidence that it's water. My brain is automatically assuming because I see a clear liquid on the road or a wet liquid on the road that it's water. That is a bad assumption to make. Okay, so my brain sometimes automatically jumps to conclusions. Hey, it's wet on the road over there. That's different than, hey, there's water on the road over there. Wet tells me there's a liquid. That's fine. That's an observation. Hey, there's water in the road. I've automatically, without even thinking about it, made an assumption that it's water, when in reality, it might not be. Okay? So that's where we have to start to kind of think, how is it that we can kind of differentiate these things? What that means is, how can we tell them apart? All right. What is an observation? Let's go over some examples. Give me some other examples of observations. Go. Go. Come on. Yes. She has a maroon shirt on. Correct. What else? Give me another observation. Only things that the five senses can detect. Yes.
You have a gray shirt.
I have a gray shirt on. Yes. The table is smooth. Okay. That would be an observation because it's based on touch. Okay. What else? Think about other things.
Does it have to be in this room?
I don't know. Your senses extend beyond this room, do they not?
But there's nothing to really taste.
I don't taste anything. All right. There we go. There's an observation. Yes.
I taste the air.
You taste the air. What's it taste like? I don't know. Okay, so, yeah, so we have to make that observation about taste. What about hearing? Hearing.
I hear a buzzing noise.
Okay, there's a buzzing noise.
I hear a fridge not there anymore.
That's right. There's not. Hey! Oh. So we make some. The buzzing could be coming from multiple places, really. In this room, my air conditioning is getting a little funky, and so is the speaker up here. It buzzes a little bit too. What else? But those would be inferences, right? We're trying to make sense of a noise. That was perfect. So she hears a buzzing. Great. That's an observation. Where's the buzzing coming from? That's an inference. We try to make sense of it by looking around and seeing what we can come up with. All right. What about, let's see, sight? We did. Taste, touch, hearing, smell.
Smoke downstairs.
Oh, yeah. The workers were smoking.
It was gross.
Okay. So not ideal. All right. Here we go. An inference is when, ladies and gentlemen, bring it back now. An inference is when you make an assumption or a prediction about something you observe. An assumption or a prediction. Okay? Not based on evidence, usually. After you make an observation, you usually make an inference about what is going on. And your brain does this automatically. It does it automatically. Okay? Now, we are going to practice. I am going to show you slides. I'm going to show you 3 slides of fossil imprints. Okay? Now, does anyone know what a fossilized imprint is? Yes?
When, like, something's been, like, pressed, something gets rock or
Okay, when something's been pressed up against a rock and it left an impression, and then that impression becomes fossilized. Okay, it basically becomes rock. Okay, so if I were to take a piece of clay and smash my face into it and leave the ultimate imprint, and then I were to set that rock in the ground for the next 1,000 years, it would probably become some kind of sedimentary rock and under pressure, and that would there be preserved forever. It'd be awesome. Okay? So, now, the thing we have to understand here is that we're not necessarily looking at geological time here. I only want you to look at this as an exercise on how we can try to describe what happened based on things we see, okay? So, right now, we're going to take a quick break. I want you to try and complete the top of that Making Inferences sheet. Okay, and I'm going to pause this recording while you do that. All right, here we go. Let's go ahead and bring the slides back up. Okay. Now let's try this again. There we go. All right, let's practice making inferences. Right now, I want you in box 1, okay? I want you to make some observations first, then make some inferences about what you think is happening. Okay, so in box 1, in that row there, it says observations, what you see, inferences, what you think. Go ahead right now and spend about a couple of minutes, okay, making some observations and inferences about this slide. I don't know. You're going to have to make some observations and some inferences. Observations and inferences. What do you see and what do you think? What do you see and what do you think? It is. This is a piece of stone that's sitting in a laboratory, and they're trying to analyze what it could represent. So they are making observations and they're making inferences about this fossil. Oh, yeah. No, this is an example. This is not a real piece of stone. Okay? It does represent a real stone, but for now, it's a cartoon drawing of one. No. Make some observations and inferences. Make some observations and inferences. What do you see and what do you think? Okay, and be very descriptive in what you think and what you see. Okay? This is how scientists look at old evidence. They see something, they make observations, and then they try to they sit around and they try to come up with all the possible solutions. Observations and inferences. Okay, are we done with box 1 or row 1? Okay. Now, the second fossil or panel adds on. Okay? So, I want you to kind of...
They're making a nest with each other. They're fighting. They got hit by a car.
Okay?
Remains all everywhere.
Observations first. You're making inferences right now. Observations first. What do you observe? What do you observe taking place right now? What do you observe? What could possibly be happening? We don't actually know. We can only make guesses, predictions, assumptions. Well, it is a continuation. Okay, these were found next to each other. This is the first one, though. Observations and inferences. By the way, once you move to another box, do not erase anything you had down before, just so you know. Okay? Do not erase anything you had down before. So here's this, this, all right? Okay? One more panel after this. There's a few there. All right, I'm going to move on. All right. Last box, observations.
Chicken survived the car crash.
All right. Hey, just
The walking duck.
go ahead and make some observations and some inferences. Purely what you observe. And what you think. I do need you to make sure that your observations do not involve any sort of predictions or assumptions. Okay? So I'm going to kind of, while you're doing this, I were to make observations only. I'm going to make no assumptions or predictions. I would say I see two sets of tracks converging to a single point or towards a single point. One set of tracks is larger than the other, but both sets of tracks have what looks to be three toes. Okay? In the middle, I might say the tracks converge, and it looks as if they are in the same relative location. Beyond that, I can do nothing else. And then in the third one, it looks as if one set of tracks moves off away from the convergence point, but that's about all I can observe. Okay, now, what do you think this could mean? All right, what are some possible conclusions we could come to? Yes, Mr. Parnett.
They were making a nest, and then the guy went out to get more nest stuff.
Okay, so they're making a nest, and the guy, we don't know it was a guy. So the larger creature left the nest to go get more nest things. Okay, yes?
The larger creature ate the small one.
The larger creature ate the small one. That's probably the most popular answer for this activity. Okay, yes?
The duck won the fight.
The duck, we have no idea that it is a duck, so we will say the creature of some kind won something, possibly. If there is even anything to win. Yes?
Well, the duck and the ostrich, I just said it was an ostrich.
Okay.
That kind of looks like ostrich. But
The duck and the ostrich.
they get in a fight, and then the duck wins and proudly walks out.
Okay, all right. Gloria? All right, someone's raking leaves, then they blow away. All right. Very, very abstract artistic approach coming from the ballerina. Yes?
At first I thought it was the map from Harry Potter. But
Okay.
then I, like, reevaluated
Oh,
it.
the Marauders map?
Yeah.
Yeah.
So then I reevaluated it and I thought, okay, so two animals just kind of like they saw each other and they met up and they did like that peacock dance.
Yeah, okay.
And then one just kind of stayed there like, okay, what should
Peacock
I do?
dance.
The other one just walked away awkwardly.
Okay, the other one walk away. All right, here is another assumption that's very common that can be made with this, is that a mom and its...
Oh, a mom and its baby.
Yeah, it's kind of ironic. It's kind of... Okay, let's see if I can bring this...
I bet he meant to do that.
Okay. A mother and its young meet up, and they kind of do the, where the mother kind of looks over the little one, then the little one hops on the mom's back, and they walk away together.
Oh, snap.
Why can't the little one stay there?
The little one could stay there.
Yeah, but then it would eventually walk away because they're
But they're ducks.
See, that's the kind of the idea, right? Because it's a fossil,
Or they're monkeys.
the little one would have had to have died here. Okay? Because there was no tracks There was no tracks leading away, and because it's a fossil, this records everything that happened over a long period of time. So we would say they met up, the little one possibly died standing because there's no imprint of a body. Or we could say that somehow the little one disappeared, and there's only two conclusions. It was eaten, or it was carried off on the back of the other.
Was that a tree by that?
They ate the bones like animals.
All right.
The bones as toothpicks.
Oh, man. All right. So this is kind of what I had you do in the boxes. We're going to kind of think of write a story about what it could mean, but we're not going to do that. All right. We're done with notes for today. Let's see how it works.